The entire concept of conic sections is based on the concept of locus. And the concept of locus, which you will learn in subsequent modules, is based on the distance formula. So we have to truly master this distance formula. Of course, you know it's this one. But if you just memorized it and learned how to plug it in, then you're missing the whole point. I want you to truly master this. So I will spend some time explaining where this came about. This came from the Pythagorean theorem. It's nothing else. It's basically you're finding the hypotenuse. And if you know that already, you can just skip it. If you didn't know that, then watch on. Suppose I am making a I should not say triangle. For example, if I'm going, say, from here and here. And suppose I want to know this distance between those 2 points. How would I find it? Well, there's only one way. We got to make a triangle to do it. And this distance suddenly becomes hypotenuse. But how? Okay, that's fine. You find the distance of hypotenuse. We know the Pythagorean theorem, how it works. If it's A, this is B, then this is distance, D for distance. Then it's a D squared is equal to A squared plus B squared. How I wish I knew what A and B are. That's easy, actually. You can count 1, 2, 3. But what if this could not be counted? Suppose all you knew was the coordinate of these points, 2, 1, right? And this one is 5, 1. How far are they? How would you find it? Well, you can count as 3, right? But can you get that 3 by looking at these coordinates? You kind of tell, yeah, 5 minus 2 would give me that. And what about these ones? Yeah, they are y coordinates anyway. What do I care? You use the second numbers, the y's, to get the y distance here, as you will see shortly. So when it comes to x distance here, all you got to do is subtract the x coordinates. 5 minus 2 is 3. Very good. Duh. Subtract the x coordinate. How come some books tell you this way, some books tell you that way? Let's take a look. If I do 2 minus 5, whoa, that gives me negative 3. Completely different from 5 minus 2. But do we care? No, because you will square. So whether you get minus 3 or plus 3, by the time you squared it, you don't care. So it doesn't matter which way the signs go. Okay, what about how high this is? How would you measure it? Let's see the coordinate here. The coordinate here is 5, 5. So the height, as I can tell, is 1, 2, 3, 4. But how can I get that? Oh, just take the y coordinate and subtract. 5 minus 1 is 4. That's how you got this. I don't have to tell you why it can be reversed like that. In fact, this can be reversed within the same formula. I could have x sub x1 minus x2 and y2 minus y1. It doesn't matter. I am just squaring it. Okay, you see the distance is just a matter of subtracting the coordinates. Very nice. But is it that simple? What if one point goes to the negative? What if I do something like this? How far is this? Whoa, one is in positive, one is negative. How would they react? Let's find the coordinates here. That is 2, negative 2. This is negative 3, negative 2. Let's find how far the x is. Would it work? Just simple-minded subtracting. Let's see. X sub 1 is 2, the first guy, minus the second x, which is negative 3. I'm subtracting, and I get 5. Whoa, it does work. What about on the y direction? What if I have something like this? Can I compute the length of this? Well, I can eyeball it and say 1, 2, 3, 4. But can I get it? 1, 3 there. And this is 1, negative 1 there. Okay, now I'm finding the height. So therefore, I got to go for the y coordinate. 3 minus this coordinate, negative 1, is 4. It does tell me the length. It doesn't matter where it goes. I just simple-minded, robotic, thoughtless subtraction would just give you the length. Yes, you could mess up by picking wrong guys and get negative answers, but you don't care because it's squared. So in this case, it becomes 4 squared because I was doing this triangle, remember? Here, 5, this second 5 minus this 1 gave you 4. So that's the distance squared, but we are not looking for distance squared. We want the distance. So you do square root, and 9 plus 16 equals square root of 25 equals 5. And indeed, this length is 5. How come I didn't put plus minus? That's because I'm looking for physical distance. There is no such thing as negative distance. When it comes to distance, it's always positive. So, to sum up, this distance formula is not something you memorize. This is Pythagoras, solved for d. You just took square root of both sides. So if I wrote it as let me rewrite this. I just take a square root on both sides and write it like that. That is the distance formula. Except how to find each side involved subtraction of the coordinates. That's why you see this kind of complicated mess. But once you see through this, this is obvious.